Amazon. And several years ago, they came out with a surprising announcement about drone delivery. And this is just some data that kind of shows you why they're interested. So at the time, they were shipping about 800 million packages a year. They're somewhat above that now. The vast majority of the orders are under 5 pounds. Some other research shows that customers are willing to pay for faster delivery by drones or UAVs. And that 0.4 is important for Amazon. They lost, this was 2016, $7 billion on shipping, because while we in the US love the free shipping, it's not really free. Somebody has to pay for that. And so obviously Amazon's very interested because that $7 billion number has actually gotten bigger in the last year. That chart at the bottom is an interesting one you'll see sometimes that kind of shows, again, part of the motivation. If you look at getting fast delivery to your home, there's a variety of options that are between $5 and $13 with UPS, FedEx, the Postal Service, and so on. Over in the lower left, you see what's been projected. This was by one of the consultants, that Amazon could do the drone delivery for about $1. And that comes out to be somewhere 7 to 10 cents a mile. And so that kind of got Amazon's attention, and it got our attention to try to look at what we could do in this space. So there's a lot of different proposals for this home delivery using UAVs to deliver small parcels. So Amazon, Google, DHL, Walmart, there's all sorts of different types of UAVs that people are looking at, the quadcopters, octocopters, fixed wing, tilt wing. There's the zipline drone. What we're really looking at is this combination of trucks and UAVs. And so here's two examples. On the right, we have Workhorse, which is a company that's been doing some work with UPS. And you see the UAV there, I guess, taking off from the top of the Workhorse delivery van. Over on the left, you see the partnership between Matternet and Mercedes. So it's Mercedes that's designed this prototype delivery van. And then there's Matternet drones, UAVs, that are landing and taking off from the top of that to deliver packages. And so this is what we wanted to look at, because the goal here is provide lower cost and or better service. And with the hybrid combination, the idea would be to exploit the advantages of both vehicles. So the UAVs give you high speed, direct travel, low cost. The truck, on the other hand, has the high payload. It can extend the range of the UAV by serving as a platform for launching and recovering the UAV. So our focus, unlike a lot of the research, was to take a step back and look at a strategic analysis of this hybrid UAV truck delivery, and basically try to address the question of under what conditions does it make sense, think about the business case here, under what conditions does it make sense to use UAVs? And so we wanted to develop some mathematical models and then compare this hybrid UAV truck delivery to a truck-only delivery, like they're currently doing, and also to UAV-only delivery from a depot, where the UAVs would travel out and back. And I want to point out that our interest at this point is really more on the logistical, the operational aspects, not on the regulatory, the legal, the technical, the engineering details. Those are all very important, but what we're going to look at is really the logistics, the operations, really try to look at the cost of this system. So let me give you a picture here to try to show you the options we're thinking about. You've got a depot there, you've got 8 customers. You could have a truck that would drive around and make those deliveries. So UPS, FedEx, they're all doing that now. You could use UAVs traveling out and back from the depot, but the UAVs have a limited range, so they may not be able to visit all your customers. Or at the bottom there, we have the UAV truck combination, where it's the same customers. Now the truck's making 4 of the deliveries, and then the UAV is making the other 4 deliveries. In this case, they're alternating, where the UAV takes off and lands at the truck at the sequential truck stops. So that's our UAV truck hybrid combination. I'm not going to do much about the approach here, but just some high-level coverage. We use what are called continuous approximation mathematical models. And the goal, again, is general insights, not to find the answer for a particular set of customers. Or it's not a discrete optimization model. We do some of that work as well. But what I'll talk about here is this continuous approximation approach, where the goal is really to come up with a general minimum cost system for making delivery with UAVs. And the key is we treat the demand for deliveries, the customers, as a continuous density. So the number of customers or number of deliveries per square mile. So instead of looking at particular locations, we have this continuous density of demand. We can derive expected travel cost expressions, so mathematical expressions that reflect the expected travel cost. And then we can analytically optimize those equations using either calculus or numerical methods to give us the best, the minimum cost designs. So the two analyses I'll talk about today quickly are delivery in day-long routes. So like UPS, FedEx may be doing, say, 8.5-hour routes, but then also looking at delivery with high service levels. So if you want to make deliveries in 20 minutes or 30 minutes or 1 hour, how would you do that? So some of the key questions there are, well, what does the optimal delivery system look like? How much money can the UAVs save, that is using UAVs? How does this depend on the key parameters, especially the density of the customers or density of deliveries? And then how useful would it be to have multiple UAVs per truck? So let me just give you a hint at kind of the basic modeling idea. Again, we have in our models the deliveries as a spatial density, again, number of deliveries per square mile. We think about the truck to model it traveling with rectilinear distance. So over on the left, you see in those three pictures there, on the left, the truck is delivering to here a set of 5 customers in sequence along a route. And you see the truck is traveling with either horizontal or vertical to reflect, say in the US, travel on the roads. And we can modify that to more accurately capture the real road distance. In the middle picture, you have the truck and the UAV alternating deliveries. So the truck itself makes half as many, and the UAV makes half the deliveries. Over on the right, I'm showing you a picture of the UAV that makes 3/4 of the deliveries. So in the right picture, 3 UAVs will leave the truck, make the next 3 deliveries, and then they'll meet back up with the truck at the next truck deliveries. And we actually looked at allowing 1 UAV per truck up to 8 UAVs per truck. Here's my one equation I'm going to show you just to give you a sense of what this all looks like. So in that blue box at the bottom, we have an expected total cost per delivery. So that's the mathematical expression we formulate. It includes the cost for the truck. It includes the cost for the UAV. It includes a line haul cost to drive out to wherever the delivery zone is, because the truck and UAV may make on a long route over 100 deliveries. And then at the end, there's stop costs. And the key is that expression is really pretty simple. It depends on only a handful of key parameters. And so if we look at the data that we need for our modeling, the truck operating cost per mile, and we actually have, at least in the US, pretty good data on that. The truck delivery cost per stop, we also have pretty good data on that. And then we need the UAV operating cost per mile. And that's where we don't have good data because, at least for the home delivery segment, they're not really doing it yet. There's a lot of testing, but it's not clear exactly what type of UAV is ultimately going to be most useful. We also need the marginal UAV delivery cost per stop. And that turns out to be a very important parameter in the model. The idea there is how much more or less does it cost to make a delivery for the stopping part, to make that delivery, how much more or less does it cost than it would to use a truck? And that's tricky because, as you know, there's many different ways that UAVs can make deliveries. They could parachute the payload, they could drop it with a tether, they could actually land on the ground and release it. And so depending on the particular mechanism for making the delivery, that marginal delivery cost could vary quite a bit. We also have the number of stops on a route, and then density of deliveries, that's the Greek letter delta there, that turns out to be pretty important, and the area that we serve. So a key question is, where do we get the data for our modeling? And again, we were interested in that home delivery sort of in the US. That was our base situation. There was a nice study done a couple of years ago by a consultant that said, suppose we want to design an Amazon-like system. They said we're going to deliver 400 million packages a year. These are within 10 miles of a depot and less than 5 pounds. We're going to use our UAVs to make 30 deliveries per day for each UAV. To do that, they estimated you would need about 40,000 UAVs and 90,000 batteries. They said, suppose that an operator could control 10 to 12 UAVs. And that is not in line with current US regulations, where you'd have to have one operator per UAV. But they said in the future, if you could have 10 to 12 UAVs per operator, you'd need 6,000 operators. And then they looked at all the costs that would be involved, the capital costs, and then the operating costs. They worked it all out and said, per delivery, it would cost about $1.20, or about 9–10 cents a mile. And even if you look at different regulations on how many operators you need, or how many UAVs per operator, you still get somewhere in the ballpark of 10 to 15 cents a mile is the way we think about this. So that's our basic data. In our models, because there's a lot of uncertainty, we did consider some pretty wide ranges. We said trucks cost $1.25 a mile. We said our UAV base case is 10 cents a mile. So that to fly the UAVs is a lot less expensive than to drive the trucks. But we varied the UAV cost from 1 cent per mile, very inexpensive, up to 30 cents a mile, which is a pretty expensive UAV. But again, this depends a lot on the type of UAV, on the range, the payload, and so on. Then the marginal UAV delivery stop cost, again, I said that was going to be important. You'll see it, well, I'm not going to show you the detailed results, but in the detailed results, that's very important. We looked at varying that from 20 cents less than a truck stop. So the minus 20 cents means a UAV delivery costs 20 cents less for the delivery part than what a truck would cost, up to 10 cents more than a truck. In general, our thinking is UAV deliveries will cost less than the truck delivery, and we're thinking home delivery. To make a delivery, the truck stops, the driver gets out, gets the package, goes to the front door or somewhere at the house, leaves the package, goes back to the truck. So that's where the truck delivery cost would be. We looked at the number of stops on a route based on the time limit. So with an 8.5-hour route, you could be making hundreds of stops. We varied the customer density from 0.01 per square mile. That would be one customer every 100 square miles, up to 500 customers per square mile. And just as kind of a metric, in the US, the average density, household density is about 33 per square mile. I think that's the number. In metropolitan areas in the US, the average density is about 128 per square mile. So we're trying to cover from pretty rural areas up to kind of urban areas. And our base case was an area of 2,000 square miles. That's a circle with a radius of about 25 miles. So that's the kind of setting that we were looking at with our models. I'm not going to show you all the results. They're in some of our papers. I give you one picture there in the lower right. Let me talk just a minute about the picture. What this is showing is percentage savings. And the point of this graph was to show the benefits we get by having multiple UAVs. So those orange arrows show the improvement of about 10 to 15% from allowing up to 8 UAVs per truck. And if you just look at the percent savings there, say take that top line, the blue line, that corresponds to a very inexpensive drone, 1 cent per mile for travel. You see savings in a very rural area of over 50%. So that's a percent savings per delivery. You could save 50% per delivery in a very rural area by using UAVs and trucks together instead of using just trucks. But as you move over to the right to more suburban areas, you see the savings decrease down below 30%. So going back to my text there, just to summarize at a high level our results, first, the percentage savings per delivery can be pretty large, and especially in rural areas. So 15 to 25% is common. With multiple UAVs, you see our savings can go up to 50% or more. However, in very rural areas, although you save a lot per delivery, there's so few deliveries that you don't save very much in total. So if you looked at the savings per square mile, that tends to be larger in more urban areas. So with greater density, you're going to be saving less on each delivery, but with more deliveries, you save more in total. So there's kind of a difference between serving a very rural area or a more suburban or more dense area. It turns out the savings are very sensitive to that delivery stop cost. And so if the UAV stops are much less expensive than truck stops, turns out you can save a lot. But if the UAV stops are more expensive than truck stops, there becomes a point when you don't want to use the UAVs. And then finally, point 4 there simply says that using multiple UAVs is very advantageous, especially in the rural areas. And the real key is to get from 1 UAV per truck to 2 UAVs. You get about half the total savings with that second UAV. Each additional UAV adds savings, but with a decreasing amount. And let me just show you, we did a little application to the state of Missouri. So this is Missouri. There's 2 main cities, St. Louis on the right, Kansas City over on the left. We said, what if you put a depot in St. Louis and a depot in Kansas City for your UAV truck routes? And then the counties are color-coded. The red ones are served from St. Louis. The blue ones are served from Kansas City. And the darker the color, the larger the savings. So we're looking at sending truck UAV routes out across Missouri to make deliveries. And the reason that a lot of the counties are gray is because we said we're not going to make deliveries to a county if it costs more than $10. So we're trying to get an idea of what would the customer pay for that delivery. We said if it's deliveries more than $10, they're not going to do it. But the bottom line on all this is for the state of Missouri with 2 depots using trucks and UAVs, instead of just trucks, you'd save about $20 million a year. And just to give you a reference, Missouri is a pretty average state. It's about 1/50th in population and area, about 1/50th of the US. So if you scaled up the 20 million times 50, you get a rough idea of what your savings might be across the US. Okay, let me talk quickly about the high service level models, because this again is a real driver from Amazon's perspective. We wanted to look at what if you make deliveries in less than an hour? And we wanted to set now routes for trucks and UAVs, so the last delivery on the route would occur within whatever our time limit is. And we have the same sort of questions there. The same 3 options we looked at before, but now we're going to think about using UAVs from the depot, like in the upper right, or the UAV truck combination, or possibly truck only. It turns out truck only is always dominated by one of the other 2. So let me give you a quick snapshot of what the pictures look like here. Here we're looking at a UAV with a range of 30 minutes. So that means based on the distances and the speed, the UAV speed we're saying is 40 miles per hour. If your time limit was 20 minutes, you could serve from the depot using the UAV only out to 10 miles. So that's all you could do with that particular UAV with that range. If you increase the time limit to 25 minutes, then there becomes a range where the UAV truck hybrid combination is advantageous. That is, it gives you the lowest cost and it allows you to extend service out to 12.5 miles. If you further relax the time limit and say we want to make 30-minute deliveries, now you get a very interesting alternating pattern where certain regions are served from the depot by UAVs only, other regions are served by the UAV truck combination. And now we're out to 15 miles. As you continue to relax the time limit, that is, if you allow 1-hour delivery, then you use UAV truck delivery for most of the region out to about 30 miles, and you use UAV only delivery only very close to the depot within about 2 miles. So kind of the bottom line is changing that service level dramatically alters the optimal strategy for serving your customers, and using the UAV truck combination extends the region that you can serve. So one thing that I've been thinking on, we haven't really written this part up yet, but suppose you wanted to serve this green region. Say the green region contains 3 towns and 2 roads. So we're looking at a fairly rural area here. One way to serve it would be to have 3 UAV depots. So 3 depots, 1 in each town. And then those red dashed lines show you the range of the UAVs. So we could serve the whole region with 3 depots. Or another option would be if we could have these launch and recover points, the truck might drive out and then launch the UAVs. We might be able to serve the same region with a single depot, but then several of these points where we're going to launch and recover the UAVs from the truck. So that's an area that we're working on. So let me wrap this up. Conclusions. From our research, we say that the hybrid UAV truck routes look very attractive. That is, they're going to give large cost savings, especially in the rural areas. But remember, that's a percentage cost savings. Your total dollar savings might be much more in an urban region, even though you save less on each of the deliveries. But the second point is key because the benefits and best strategy really depends on the operating cost of the UAV, the marginal stop cost, the customer service level, 30-minute, 1 hour, 2 hour, 3 hour delivery, and also the UAV range. It seems clear though that trucks can extend the range, and using multiple UAVs per truck is very beneficial. But the fourth point I think is a key one that says the business case still requires both a better understanding of the near optimal designs and operations, but also it requires good data. And right now, we're a little bit lacking in good data for the home delivery case, largely because some of the private sector firms, the Amazons, FedExes, and so on, aren't very forthcoming for competitive reasons with the data. So let me move to just a couple questions to wrap this up. And the most important question is really the first one, and that's what can we do to help? So are there some things, some settings that we might be able to analyze in the UAV for global health settings using our modeling approaches? Number two, we'd like to know more about payload delivery applications in global healthcare. So what's the payload? What's the demand like? How is it spread around? What are the depot, the launch site, delivery site requirements? We've looked at what's available online, but there's a lot of information that we would like to get there. What are the types of UAVs that are used? What are the staffing requirements? And then number three, is there a way to combine UAVs with either trucks or maybe boats in some settings to try to achieve the lower cost and the better service? And number four, are there some applications maybe with near future technology on the UAV side that are not yet being considered? And then this is the sort of data, I've talked a little bit about that we would love to get for different settings so that we could use that in our models to be more accurate. And really, that's the end. So I just want to thank you for your attention.
Great. Thank you, Dr. Campbell. Yeah, if you could just back up 2 slides, Dr. Campbell, where your questions begin. We like to open this up now just to start discussing, or maybe if any of you who are attending, if you had any questions during his presentation that you'd like to ask, or if you'd like to kind of at least attempt to answer some of his questions as it relates to maybe your context and your work in the global health supply chain. We do have about 30 minutes left, so I'd like to just open it up to you with any questions or comments or discussion.
I have a question. I'm curious to know how much you can divorce the operational questions from the regulatory. So, for example, what you've shown us here, I think obviously makes rational sense. But how much will it be facilitated, or how much will it be possible given the regulatory environment, and how much will this kind of type of research steer or influence the regulatory environment?
Yeah, that's a very good question, and I think it's very different between sort of the home delivery and the global healthcare setting. In terms of the home delivery, I guess, I don't know if I'm cynical or what, but I think if there's a lot of money to be made, and our research kind of suggests that, and the interest that's being shown from companies like Amazon suggests that, if there's a lot of money to be made, then the way the regulatory system in the US works is there will be a lot of efforts put forward to changing the regulations. And I think perhaps one of the best examples of that is what FedEx did to change the regulations to make that company as successful as it is. Because when FedEx started, they were not allowed to use trucks. And so it made absolutely no sense to use planes for some of the short haul deliveries. And they worked very, very hard through the congressional process to change regulations, which ultimately were to their favor, and they would claim were to the customer's favor as well. So I think in the US, at least, I guess that's kind of my view, that the regulations can be changed. And if there's a lot of money to be made or a lot of savings that will occur, there will be a lot of pressure to change those. I think in the global healthcare setting, what's been interesting is to see how much or how well different organizations, as I understand it, have worked with the governments to get favorable regulations that allow them to do things that you can't do in the US. And so I think that's a very encouraging situation. And I think a lot of credit needs to go to whoever has been working very closely with those governments for a long time to get that done. So does that sort of answer your question?
Yeah, thank you very much.
For all future questions, if you could introduce yourself with your name and who you're affiliated with, that would be great. I think, Olivier, you're going to...
Hi, this is Olivier. So the previous question, I think, was just to fill this gap. The previous question was from Joel Kaiser from We Robotic. Is that correct?
Yeah, that was me.
Okay, thank you, Joel. So we have a question from Sarah De La Rosa, who just texted. She may not be able to get on the microphone. Her question, Sarah De La Rosa first, is the interagency supply chain UAV coordinator. So that's a recent group that she's helping donors in the global health space coordinate and give some information from them so they can direct their investment towards testing UAV in the global health. Her question is, what would be the additional staff requirements? Do you envision that UAS operator will always need to travel with the truck driver, or would drivers be trained to operate the UAS?
I think what we're seeing in the future, and again, it's unclear how real that's going to be, but in the future, they're envisioning sort of fully automated systems. And I don't know if I included a picture of that Mercedes van, but there are some, it may be more public relations than reality at this point, but there are some good images of what the inside of that Mercedes van would look like. And it's really a fully automated operation where the UAVs are landing and taking off and reloading without the driver intervention. And to take it a step further, there's people looking at on the research side having driverless trucks with the UAVs as well. So you would have no people involved, which of course is one of the big savings. Let me jump back just to that one analysis of the cost, because it kind of stuck out to us. When you look at the major costs, at least for this home delivery setting, it's really labor. And so out of a total of about $480 million for this Amazon-like system, $300 million of that is for labor. And that's with a pretty generous assumption that, at least in the current times, a generous assumption that each operator can control 10 to 12 UAVs. And so because labor costs are such a large component of total cost, there is a lot of interest on the business side from replacing the labor. And UAVs do part of that. Driverless trucks would do another part. So in the ideal world, the staff requirements are very small. There are a lot of tests, both in healthcare settings as well as other settings, with fully automated docking stations for the UAVs. So I guess we kind of sidestep that issue and say it's a technical engineering issue that seems to be something that people are working on, and it seems solvable. So does that answer your question?
Hi, James. I'm jumping in now here. Do you hear me?
Yes.
Hi, thank you so much for that answer. That's a very ambitious outlook for how this may work, but hopefully that will come to the point that this is doable. So basically what you envision is that there will be like a central operating center somewhere in that state controlling all the fleets of trucks and UAVs, correct?
I think that's what's envisioned. As to whether that's going to be a near-term reality is uncertain. I guess the other thing that's always lurking in the background is the military experience in controlling UAVs halfway around the world. So again, the technical side, I think it's there. There are very large savings by eliminating the labor component, and I think that's applying the pressure. Going back to the global healthcare setting, as I understand it, which is limited, the environment's going to be so completely different that eliminating the staff and the labor component may not be wise or possible in those settings. So I think that's kind of one of those areas that we'd really like to learn more about.
Yeah, absolutely. I think there are some country challenges that would need to be overcome in cases where even trucks or fridges cannot be repaired because there's not enough skill set to maintain those systems. Yeah, that's an additional aspect we need to look into.
If I may just add a comment to that later statement, it is true from if you think about the maintenance and the support of the technology of the UAVs, for example. But when you think at delivering health commodities to the last mile, to health centers, to hospital, the people who work at those health center and the hospital and so on are health workers, right? And so the skills to start with handling UAVs and loading and unloading and reloading and this whole thing would require some additional training for them. And one of the idea is to try to limit the need of the health worker to interact with the drone and gaining additional skills, because it's taking away their time from what they're supposed to be doing, which is taking care of people. So taking away as much as possible the human resource component is something that will need to be taken into consideration. I think what you're presenting there, it's pretty futuristic. And it's good to have a vision, but I think the technology is far from there, but it's hopefully moving towards that direction. I think that's a good insight.
Yeah, just let me add one other comment on the labor cost, sort of just to give you a sense. That study I showed earlier that was estimating costs, they were saying that a UAV operator will cost $50,000 a year. That was kind of their labor cost. When I look at the settings in Rwanda or South America or wherever, I have no idea what the right number would be for the cost of labor. And so that's the sort of thing that we would love to get, because I think when you put in the different numbers for the different settings, you may get very different conclusions.
That's correct. Yeah, totally right.
I have one more question to James.
Yes.
Are you participating in the FAA IPP program, the tests in the 10 states that have been approved by the FAA?
No, we are not doing any sort of testing. We're really doing research with modeling and optimization. We do know there are some academics, mainly again more on the engineering side, that are more involved either with companies or with the government in various ways. But our focus has been kind of the strategic level modeling to try to get at this question of, does this whole idea make any sense? And I guess so far our results are suggesting that it kind of seems to.
Okay, thank you. I'll leave the floor to everyone else.
Hi, this is Matiko from based in Tanzania, from JSI. Thanks a lot to Dr. Campbell for the presentation. I think it's very informative and very interesting. My question, or something that I really need to understand more, is on the operational side and also regulatory side. So I'll share you an example from the experience that we have had. Here in Tanzania, you need to have the permit, for every flight path or route that the UAV will be flying, and especially if the UAVs will be flying out of sight. And also the question of, like, for these tracks, do we need do they need to be like specially made for enabling this UAV to take off and landing? And also, do we need like special only one category of UAV? Let's say the UAVs with vertical takeoff and landing that can only be used for this situation, or even others. And the other thing is linking also with public health. In terms of geography, we have these hard to reach facilities. For example, we are doing testing across the lake where the UAV flying over to islands. I don't know on this those different aspects and regulatory issues there, because they are kind of hindering or complicate if we say like we want to apply this, because regulatory here is very strict. You need to know, you need to get that clearance where you are flying, and you need to inform the Tanzania aviation authority. I'm flying now. I'm taking off. I'm landing. I don't know how you can comment on this. Thanks.
Yeah, I think those are very important questions, certainly, and the real world considerations. Just a couple of comments. One thing that's interesting to me from the research side you mentioned the flight paths. Almost all of the academic research that looks at UAV or drone delivery settings assumes that the UAVs fly in straight lines. And of course, that's not the case. And there's a variety of reasons, like you say. There may be certain flight paths. You may have to avoid certain areas, whether it's mountains or restricted zones. And so I think there's an opportunity there for the researchers to do a little bit better job in considering that. Still, though, I think because, at least when you do a comparison to something like truck, I was saying $1.25, $1.50 a mile is a reasonable truck cost in the US because we have great infrastructure. UAV cost is going to be a lot less than that, the cost per mile to fly it, I think almost anywhere. But I'm not really sure if you're using motorcycles for deliveries or other methods in Tanzania or elsewhere, those truck costs or the cost of the alternative, if it exists, could be completely different. Also, you mentioned the takeoff and landing requirements, I think, which is a tricky issue that hasn't really been resolved. When you look at the testing for home delivery, like in Amazon, they're making these deliveries by the UAV landing and releasing the package in somebody's front yard. There's a whole host of issues how you actually do that. When I see what, say, Zipline does, they're dropping the payloads by parachute. There has to be someone there to collect it. All of those things we do need, I think, to model a little better. But for our sorts of models, what that comes down to is these costs for making that delivery stop. And that's one of those things that I said earlier was very crucial. If you can get away with parachuting the payloads, to me, that would reduce the cost as opposed to actually having the UAV land or something else. But again, for our modeling approach, the goal would be to say, either this seems to make sense or not. And then I think that gives you ammunition on the regulatory side to say, we're going to be saving lives, saving money, whatever it is. We need to work on the regulations to do some more testing to see if this is going to really be beneficial in practice. So I kind of see this actually going hand in hand, at least from my perspective.
Yeah. Thanks so much. I think that makes sense, and it's very, very interesting.
Hi, this is Olivier from Village Reach. I have a question in regards to the fact that you mentioned, the percent cost saving per delivery seems like promising, especially in rural area. And I want to understand better this statement. because looking at the global health and its application and lesson learned and how we can extend that learning from this global health setting, there's also two use case like in the urban area, high density customers, like you would say, but you also have where you would serve a region or health centers that are challenging to reach due to environmental condition, road or islands. And so where we're starting to look at use of UAVs. But in those cases, it's a more rural density. And you said that the results of cost saving in your model is sensitive, very sensitive to stop cost. And I'm guessing that that is related to the marginal UAV delivery cost, right? Where there is probably a great variability depending on how the UAV would be actually doing the delivery itself. So I'm not talking about doing the flight, but like I'm talking about dropping versus landing, and so need to land, to drop, and then take off and things like that. Can you extend a little bit on how can we understand better the cost driver and this use cases? I understand that the access to data is limited, and what are you doing? What is your strategy to start gathering more data, especially for this use case?
Yeah, that's two good points you made, at least two. But one on, let me go back to the first thing you were talking about, the percent savings per delivery versus say a savings per square mile. The interesting case, I think, for the home delivery with say Amazon is they may have the choice of either serving a very rural area where they could save, a lot. They could save $5 per delivery, say, but if there's not very many deliveries, because it's a very rural area, they're not going to save much in terms of total dollars per day or per year. On the other hand, they may only save 50 cents on a delivery in a suburban area, but if they're making a whole lot of deliveries in that suburban area, those 50 cents are going to add up to be a much greater bottom line impact. And so part of this to me leads toward the marketing part of it, which is different for home delivery than I think global healthcare, where Amazon ideally would like to have everybody receiving UAV delivery. So the denser the deliveries, the easier it is from the logistics side. And that's true, I think, for global healthcare or other areas. But it's a little bit easier in a suburban or urban area to increase the penetration of UAV delivery to a much greater number through marketing, pricing, and so on. I think what my limited understanding of the global healthcare space says, you have a limited number of customers, if you will, or delivery sites, and you can't really increase that by 10 or 20 or 100-fold because there's not that many sites you want to deliver to. And so I think with a lot of the global healthcare, you are sort of limited to that more rural case where you can save a lot percentage-wise on each of your deliveries using the UAVs, but you're not going to see the same sort of impact that you would for home delivery, where if every other house is receiving, I think in a suburban area, if every other house gets a UAV delivery, you can be very efficient. So that was one point. The other point about the stop cost, what are we going to do? We're a bit stymied, to be honest, from the UPSs and the Amazons and so on. We are trying to interact with the folks in those companies. They are very unwilling to share data. Again, it's for competitive reasons. And so that's one of my hopes would be either through some of the engineering-oriented research where they're actually doing some field testing out of universities on how does all this work. And so we can collect data that way. The other hope I had was when I see a lot of great pilot testing being done with UAV delivery and global health. And I've started to see some data and some reports appearing on what it would cost. But back to your issue of stop cost, I think there are some cases, I hope, where we could actually do field work to collect the data for what would that accurate value of stop cost be for parachuting blood as zipline does, or for making deliveries with other types of UAVs, whether you're using a tether or you're actually landing an octocopter, whatever it is. So I'm hoping that the public sector and the global health community might be a little more open to some data collection that would be specific to their problems.
Yeah, that makes sense. And I'm wondering if in the audience, is there any UAV manufacturer online? And if yes, do they want to comment on or do they have any opinion on stop cost? Do we have any UAV manufacturer first on the line? No? Oh,
I guess not.
Okay, I guess not. There are some UAV manufacturers who are part of the UpDoc, but I guess not today.
And there is, I will suggest one other thing, there is a big trade-off there, and I think this comes back to some of those issues of labor costs. And is it cheaper to have a labor-intensive method of making deliveries, or to have a very automated method which would replace some of that labor with a large upfront investment? And this comes back to then that question of density, because if you're only making a few deliveries, it's tough to cover that fixed cost, whether it's on the depot side or the takeoff and landing side. Once you're making a whole lot of deliveries, you can spread that fixed cost over those deliveries. But again, in the US, as I said before, say a drone operator, or think about labor cost here, I'm not well versed on how they compare to Tanzania or Rwanda or Madagascar or other places, but I know they're going to be very different.
Thank you, Doctor. I see, have you been interacting with, there's other academic and groups such as, well, academic and private sectors such as Lamasoft and the Hermes team. Have you been talking with them? Because they've done quite a bit of modeling in the public health or global health area. That may be also a good people to talk with.
Yeah. I did go to the Lamasoft conference last year, where they had they had a session on UAV, and that was really where I started to get excited about it, to meet the people from Village Reach and USAID and other places. And so I'm in touch with a couple of them. We're hoping to have them actually come out to St. Louis and do a talk. But I think Sid Rupani is down in South Africa. He's one of the people there, and then I forget her last name, Nalima.
Nalima, and I think Nalima is on the phone right now. Nalima, are you there?
Yes, yes.
Yes. I had met Nalima, I forget where. But yeah, we're very interested in sort of working with them. I think they have a little bit different interest in this than the Amazons. And certainly any data, or not just data, but also could we alter our models that would be a better fit for important cases in global healthcare?
Yeah, absolutely. I think we've been focusing our modeling efforts, answering similar questions, working with various partners that are on this call as well. But I think the variables and the modeling inputs that we've been learning about, which apply to the global health setting, and kind of the lower resource setting, especially when you have different types of UAV vehicles, is definitely something that that we can share, and I think kind of learn from each other's modeling approaches.
Great.
Does anyone else have any other questions or comments? I did just have one observation, just in terms of the model you're using. Obviously, with Amazon and UPS, those are unique destination points every delivery, whereas maybe on a day-to-day basis in the health supply chain, it'll be a routine, say, delivery if we're doing lab samples or vaccines resupply to a clinic or a health post. So maybe for future modeling of your hybrid approach, you would do it more in a fixed setting where you say, you know, every week or every month we always go the same route. So you kind of you always know the distance and the average times it would take with a truck, and then you could just change it with.
Yeah, I think that's a good. I think that's a real good point. And when you're looking at a fewer number of delivery sites, then I think a more discrete approach from the modeling world would make sense, because like you say, you have fixed locations. I think the interesting thing to get into there would be some of the variability. And so that might lead to more simulation type modeling where you could handle whether it's maintenance issues or weather issues or the sorts of things that go wrong in the real world that aren't at this point in much of the academic research. So I think you're exactly right, and that's a good point.
Mm-hmm. All right. Well, if I guess just anyone else want to talk or say or ask a question? Okay. Well, thank you all for joining. Thank you also, Dr. Campbell. We have recorded this session, so we will make it available with notes as well. Of course, I hope you guys continue the conversation offline with each other. And we're excited about, we have some future events coming up that we're going to be scheduling over the next couple months. So stay tuned. We'll be updating you that through the UAV for Payload Delivery newsletter. And of course, continue to send in your links and ideas. I really appreciated that. So thank you all, and have a great day or evening wherever you are. Thank you.
Thank you, Paul.
Thank you, Dr. Gamble.
You're welcome.
Bye, everyone.
Bye.
Bye.
Bye, everyone.